What is this?
Standard form.
Standard form, right? Standard form of a quadratic, right? Okay. So what I want us to do today is I want us to complete the square on this. You think that's something we could do? Yes? Okay, good. So if it's something you think we can do, what should we do first to complete the square on this? There's actually two things we could do first. Which one do you want to do first?
Will we put the constant on the other side of the...
So you want to get rid of c. Okay, so if we move c, subtract c from both sides, we get ax squared plus bx equals negative c. Okay, since we chose that first, there's only one thing we can do next. Anybody remember what we have to do next?
Divide the b by 2.
We can't do that yet. That's a good thinking, but we can't do that yet. What I need you to remember is that we can only do that step if a is 1, right? Is a 1 right now? Yeah, I don't know, right? I can't prove that a is 1 or not, so the only way I can prove that a is 1 is by what? Dividing it, right? So I have to divide everything by a. That by a, that by a, and that by a. When I do that, what happens with this? That's 1, right? That simplifies to 1. So I have just x squared plus b over cx, or c, what the heck? A equals negative c over a. Is everybody okay so far? That's a weird, creepy looking a. Sorry about that. Okay. Now what do I do?
Now you can divide it by 2.
Divide it by 2 and square it, right? But it's a fraction. Is it okay if we do that instead? Multiplying it by 1/2? All right, so what do we get if I multiply it by 1/2? B over 2a. And what are we going to get when we square it? How do we square a fraction again? Square the numerator, square the denominator. That's exactly right, right? Okay, so what am I going to get? B squared over 4a squared. Very good. But I just added it here. Oh, to both sides, right? So if I added it here, I have to add it here. B squared over 4a squared. Okay so far? Now what? Where do I take my trinomial? To a binomial. Remember that? Okay, where do I get my binomial? Okay, so x plus, what goes in this spot? So either half of this or square root of that. Remember that? So b over 2a. Now on this side, what do I need in order to add fractions? Common denominator, right? What's the common denominator between a and 4a squared? Can I make this become a? No. Can I make this become 4a squared? Yes. So tell me what the common denominator is then. 4a squared. So what do I have to multiply this by to make it become 4a squared? 4a. And if I multiply the denominator by 4a, very good. Multiply the numerator by 4a, right? So this one right here is, let's see, I'm going to put everything in the right order. So negative 4ac. Well, now that they have a common denominator, can't I go ahead and add that numerator as well? All over 4a squared. Now what? Okay, square root both sides. Square root that side. Square root that side. Okay? So what do I get on the left-hand side? If I'm square rooting something that's being squared, what do I get? That's something, right? That thing. So x plus b over 2a. Right? Equals, wait, who put the root sign in the problem? So what else do we have to remember? Very, very good. Very good. Plus or minus. How do we square root a fraction, though? Like how did we square a fraction? Square the numerator, square the denominator. So how would we square root a fraction? Square root denominator, numerator, square root denominator, right? Okay. So plus or minus the square root of, I can't, this is not something I can take the square root of. But what about the denominator? I can, right? I sure can. That is 2a, just like you said. Okay? Everybody okay so far? Now to solve for x, I subtract b over 2a. So x equals negative b over 2a, negative 4ac plus b squared over 2a, except these are fractions with the common denominator, so can't I combine their numerators? And at the same time, if I just rearrange some stuff that I know, oh my goodness. It is a quadratic formula, isn't it?
I think I solved this one coming.
So for the record, this is not the only way to get the quadratic formula. There's lots of different ways to derive the quadratic formula. Okay? This is the way that I thought you would understand. And I don't mean that disrespectfully, right? There's some ways that I looked up. I was just looking up some ways earlier because I know this way, but I was like, is there any other way? I was looking up some of them earlier, and I was like, I don't know what this means. I don't know where this is coming from. It's crazy stuff, right? This is a way that we just learned at the end of last week. We learned how to complete the square, didn't we? Or was it even, yeah, it was last week, right? So I thought we could probably go through all the steps and derive the quadratic formula on our own. So you could see one of the places that it comes from. Does that make sense? Now, am I going to ask you to recreate this? No. Was any of these steps hard?
No.
No. Was it messy? Oh, very, right? Tons of letters. The only number in here is the squared, right? Otherwise, it's all letters and the 2 because we squared stuff, you know, divided by 2, whatever. So, well, I guess there's a 4. Sorry, I forgot the 4. But you get what I'm saying, though, right? A lot of letters, but I wanted you to see where it came from. Does that make sense? Do you remember this formula? Bet. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I don't think everybody remembered it.
I remember.
You got to try a little harder.
I don't need to sing this song.
You ready?
I can just sing this.
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Sam wasn't.
Oh, okay, one more time. For the record, he wasn't the only one. You ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Hey, by the way, Colm wasn't singing it.
What's it for? What's this for?
So we can remember it, right?
How to find the solutions of quadratic. Yeah. Remember, like we talked about yesterday, it doesn't do any good. It doesn't do any good to know a really cool song with a really cool formula if we don't know what it's for, right? We can use this to solve, like, what kind of quadratics can we solve with this?
All of it?
Anytime.
Any type, right? Okay, now, this is, again, not required information for you to know, but I thought it was interesting, so I'm going to tell you. Okay?
I remember Colton asked you
This
yesterday.
formula,
Oh, yeah.
this formula is called this in Brazil.
It's what? It's Brazil.
And that in India. Now, I 100% doubt that they use the word formula,
Which one's it?
right? But this one is from Brazil, this one's from India. Now, let me tell you what I know about it, okay? The Quadratics in general were first solved by the Babylonians and Egyptians in 2050 BC, between 2050 BC and 1650 BC, but they were geometrically solved. It wasn't algebraically, it was geometrically solved. Okay? Euclid also used some geometric models to solve in 300 BC. He's a pretty famous mathematician. Okay? Diophantus, who is Greek, had a more algebraic than geometric way to solve them, but still was kind of pushing geometric, and that was in 250 AD. But the way he did it, you could only find one root. Okay? Oh no. Brahmagupta from India could only also find one root in 628 AD, but the way that they solved math problems back then was like in paragraph form. Like you wrote the steps out. It was words, right? Okay? Then in the 8th and 9th century, Siddhara, who was an Indian, he published something that to solve a quadratic that was very similar to Bhaskara, but Siddhara's work and Bhaskara's work is lost, we think. Okay? But do you understand why it's called these things now in these places? Bhaskara and Siddhara. Okay? In 9th century Persian named Muhammad
Hey, I was right.
Ibn Musa al-Khwarizmi. I'm sorry, I don't know how to say it. He solved it first algebraically. Okay. Simon Steven, who is Flemish, he's from Belgium, in 1594, he solved quadratics algebraically, covering all cases. Okay, and then René Descartes, who is French. You guys have ever heard of him before?
Wait,
You
say his
have.
name again. Wait, say his name one more
René Descartes. Descartes. He was French. You've heard of him before because when you graph on an x and y plane, that is called the Cartesian plane from René Descartes. Cartesian. Okay? And that was in 1637, and he solved lots of special cases and used probably the formula we know today, this one. Okay? I'm not making you memorize any of that. I just thought it was interesting. This is not something that like I made up or like my grandparents made up. Quadratics have been needing to be solved since 2050 BC. A long time ago, at least. Okay? So I just, like I said, I thought that was interesting and thought you might be interested in that. Okay?